Hi all. Uh, Shruti, over to you. Am I audible?
Yeah, Varun, you're audible.
Okay. Okay, sir. Shruti, you can start the meeting.
I think we can wait for another 2-3 minutes. We can start by 7:05. Okay.
Okay, sir. Okay.
Hello. Hello.
Yes, Rudy, you can start the proceedings at 7:05 p.m. Okay.
Okay.
Hi, Shruti, you can start now. It's 7:05.
Okay. Good evening, one and all. I extend my heartfelt greeting to all the dignitaries and residents in attendance. We are glad to welcome each of you to take part today's event. Today, the IEEE Education Society Kerala chapter is association with IEEE Education Society Hyderabad chapter is here with an amazing talk session on the topic Future Trends and Research to Enhance Learning in Engineering by Dr. Nurzal Effiyana Binti Ghazali. The specific objective of this session is to provide an insight into the future trends in teaching and learning methodologies in engineering. In case of any queries during the session, feel free to drop them out in the chat box. To set foot into our event with a warm welcome note, I invite Mr. Varun Kumar M. from the professional team of IEEE EDSOC Kerala chapter. Over to you, sir.
Hello, hi, and welcome to this wonderful session organized by IEEE Education Society Kerala chapter and IEEE Education Society Hyderabad chapter. Today we have with us Dr. Nurzal Effiyana Binti Ghazali. She is a speaker for introducing us with the topic Future Trends in Trends and Research to Enhance Learning in Engineering. Dr. Nurzal is a senior lecturer at the University of Technologi Malaysia and also the Deputy Director of Center for Engineering Education at the university itself. She is an engineering education researcher with a PhD in electrical engineering. She is also an IEEE member, also a graduate member of Board of Engineers Malaysia. She's been awarded with Sakura Science Plan of Japan's government in 2019, Anugrah Pakitmata Kamalong Award in 2019, to name a few. Her research interests include mobility management, network selection in heterogeneous networks, network communication protocol, and also engineering education research. I welcome with a warm heart Dr. Nurzal Effiyana Binti Ghazali to this session. Over to you, ma'am.
Thank you, Mr. Varun Kumar. Okay, hello. Hi, everyone. Okay, I am Nurzal Effiyana Binti Ghazali. Okay, let me share my slide. Okay, can you see my slide?
Yes, ma'am.
All right. Okay, so I am Nurzal Effiyana Binti Ghazali, and currently I am a Deputy Director at Center for Engineering Education, and I am a Senior Lecturer of School of Electrical Engineering. And today I'm going to share my experience, my thought, okay, about future trends and research to enhance learning in engineering. But before I start, okay, I want to get your opinion about learning. Can you please go to www.menti.com and fill in the code 48118763. Okay, I shared the link in the chat area as well. You can just click and go to www.menti.com. Can you access it?
Yes, ma'am.
Okay, so currently I am close. Okay, I'm closing the results. Okay, I don't want the result influence other friends. Okay, hope you can participate, giving your opinion about learning. Okay, now we have three audience participate in this survey. We have 47 participants, so I hope we get more results. Huh? Okay, give your meaning. What is learning? Give your opinion. Please type. Okay, so let me type the code. Wait,
Could you please share the?
Okay, I share the code on the chat area. You can just copy and paste the code. It's only 7 people who participate. I am expecting more. Just give your opinion or your understanding about learning. So I'm still waiting because we only have 12 at this moment. There is no right or wrong. Just give your opinion, your understanding, what is learning. Divya, can you please write it down in the menti.com?
Sorry, I didn't get you.
Okay, can you please write it down in menti.com? I shared the link and the code again. Okay, so now we have 15, 16, and then I'm going to open the results. Okay, so as you can see, I think you can see my menti.com, right? Now you can see the results. Okay, the biggest word here is studying. Okay, so this biggest word means that many of you give this word which relate to the learning. And okay, now we can see understanding, studying, knowing, engineering education, creative ideas, anything is learning. Okay, reading, inventing. Okay, we have understand, researching, understand about critical thinking, electrical, quite knowledge, okay, experience, exploring, personality development, listening, earning knowledge, acquiring knowledge. So now we can see a few meaning from our friends here related to the learning. Okay, for your information, explanatory dictionary define learning as training, assimilation, memorization, gaining knowledge, understand, or learning by experience or study. And we can find a few words related to this in our menti.com. However, the definition given by this dictionary has been argued by previous researchers and philosophers. Okay, now I'm going to share my PowerPoint again. Okay, previous researcher, philosopher, gave a different meaning of learning. Okay, as you can see here, Kimball in 1961 mentioned that learning as a relatively permanent change in behavioral care potential as a result of reinforced practice. Okay. Okay, and then Bandura said that continuous and is not dependent on reward. Skinner, learning is the formation of a new behavior. The human development is model, while Vygotsky mentioned that social learning tends to precede development, where Vygotsky believed that social will improve our knowledge. Okay, while Piaget, having your own cognitive schemes or structures, build and rebuild schemes to understand the world. So here I just share our previous researcher, previous philosopher related to the learning. And here you can see that there is a lot of meaning And we have a recent researcher give their own definition of learning. Okay, because learning is an inexhaustible process. We learn new things every day, and learning keep evolve from time to time. That's why the definition of learning is various. Okay, so now, even though we have seen various definitions of learning, we can identify a common structure in the definition, which there is a change in behavior, and the change is the results of experience, and the change is sustainable. So this is the common structure of learning. To achieve this, there is a process involved. Okay, and based on Christina 2019, there are 4 phases involved in learning process. The first one is perceiving, receiving, actively recording information and knowledge. After we receive, we try to understand it. So understanding is the second phase of the learning process. After we understand it, we try to store the information that we obtain. So this involves internal processing, organization, and storage of information. After that, the last learning process is recognition, reproduction, application, or transfer of learned knowledge. So when we learn something, we need to explain, we need to transfer the knowledge. So based on this learning process, I can say that learning is not simply sit and listen to the teachers or lecturers. And it is not simply to memorize everything transmitted by teachers or lecturer. So the definition of learning and this learning process is actually related to learning sciences. Okay, and learning sciences is important because it will help us to improve our knowledge, which later will give impacts to our students and the way we deliver the content. So what is actually learning sciences? Okay, learning sciences is interdisciplinary field that studies teaching and learning. It has been introduced in 1991. Okay, the goal of learning sciences is to better understand the cognitive and social processes. Okay, when we have this knowledge, the cognitive knowledge, the social processes knowledge, we can contribute to the most effective learning, and we can redesign our classroom and other learning environments. Thus, the result of it is people will learn more deeply and more effectively. So why this learning sciences is important and how it can contribute to us in engineering. Okay, so the first one is to us educators. Okay, knowing about new science of learning can help us to be more effective in our classroom. This is for us educators. Okay, the second one for the administrator. Knowing about these learning sciences can help you administrators to lead school or institution for the 21st century. And for the education entrepreneur, it will help you to ground innovation in how people learn and design more effective learning environments. And for education researcher, you will relate your own studies to these learning sciences and see how you can participate in building the schools of the future. So by having this knowledge in learning sciences, okay, we can identify issues in the 20th century education. Okay, so issues in the 20th century education is schools and education institutions were designed based on assumption, okay, which give a result of knowledge is a collection of facts about the world and procedure for how to solve problems. The goal of schooling is to get the facts and procedure into students' head. Educators' job is to transmit the facts and procedure to the students. Simple facts and procedure should be learned first, followed by progressively more complex facts and procedures. And the way to determine the success of schooling is to test students to see how many these facts and procedure they have required. Okay, now I want to know, do you have this kind of experience when you was a student? Please write something on the chat area. Do you have experience where your teachers or your lecturers just transmit the facts and procedure in your class? Please write something in the on the chat area which relate to this issue in the 20th century education. Do you have experience with this kind of education? Need to memorize everything and then write it down in the test or final. Can I get one or two opinion? Yes, Abilash, right? Historical dates, name of people. Okay, so we need to memorize everything, right? What about the others? Yes, during your school's day. And this, for information, I agree with this statement because I have same experience with you. Okay, when I was a student, I just sit and listen to my teachers, my lecturers, and I try to memorize everything that they give, right? That they gave during the class hour. Then during the test or final examination, I just write what I can remember on the paper. It doesn't involve my this involve analyzing, synthesizing. Okay, it means that previous education is like a rote learning. However, okay, we are now in the 21st learning century. The goal of education is a little bit different. Okay, so now we need to move from this traditional method to the deep learning education or the future education. All right. So as you can see here, for future education, we want learners to relate new ideas and concepts to the previous knowledge and experience. We don't want our learners to treat course material as unrelated to what they already know. Okay. And in the future education, we want our learners to integrate, to integrate their knowledge into interrelated conceptual system. Okay, we don't want our learners to treat course material as disconnected bits of knowledge. Okay. And the next point of the future education is we want our learners look for patterns and underlying principle, not to memorize facts and carry out procedure without understanding how or why. Another point of future education is we want our learners evaluate new ideas and relate them to conclusion. Okay. However, in the previous or the traditional classroom practices, learners have difficulty making sense of new ideas that are different from what they encountered in the textbook. They're going to be panicked if they see something that is not in their textbook. So that is the traditional classroom practice. Another future education is we want our learners understand the process of dialogue through which knowledge is created and that they examine the logic of an argument critically. Okay, we don't want our learners to treat facts and procedure as static knowledge handed down from an all-knowing authority. And the last point for the future education is we want our learners reflect on their own understanding and their own process of learning. Okay, we don't want our learners memorize without reflecting on the purpose or on their own learning strategies. So we need to move from the traditional classroom practices to the deep learning of future education. But how we can make a move? To move forward, we cannot run from research related to the engineering education. As reported in the research agenda for the new discipline of engineering education, there are 5 research areas involved, which are engineering epistemology. Engineering epistemology is a research on what constitutes engineering thinking and knowledge within social contexts now and into the future. The second research area is engineering learning mechanism, which is research on engineering learners developing knowledge and competencies in contexts. The third research area is engineering learning system, which is research on instructional culture, institutional infrastructure, and epistemology of engineering educators. The fourth research area that has been discussed is engineering diversity and inclusiveness, a research on how diverse human talents contribute solutions to the social and global challenges and relevance of our profession. And the last one is engineering assessment, a research on and the development of assessment methods, instruments, and metrics to inform engineering education practice and learning. So these are the research areas that can make us move to a future education. And these research areas, okay, can be said that the trend, research in engineering education. In addition to this area, there is one area that gained interest during pandemic, which is technology in education. So here I divided technology in education into 2. The first one is technology tools for learning. The second one is technology across the curriculum. Okay, for learning, tools can be used for representing knowledge and for organizing knowledge. While across the curriculum, we can use tools, for example, for reading and writing, for mathematics, for design, and for communication. There is a lot of example relate to the technology across the curriculum out there. I just give you 4 in this slide. And when we want to relate technology with us, educator, so I divided it into 3. Okay, it involves instructional tools, management tools, and assessment tools. So we can use technology to improve our delivery in class. Due to this, I would like to share with you one video. It was in 2013 where a physics teacher, Andrew Vanden Heuvel, took his online physics student on a virtual field trip to the world's largest particle accelerator at CERN. So let's watch this video.
I think it's back here. There it is. Would have been cool to be an astronaut. My name is Andrew Vanden Heuvel. I'm a physics teacher from Grand Rapids, Michigan. Through college, I was embarrassed to tell people that I wanted to be an astronaut. It's like I want to be a princess who rides horses while being a police officer or something. It's just like, it's ridiculous. I found my passion in teaching.
Can you say conservation of angular momentum?
I'm what you'd call a non-traditional teacher. I teach primarily online for students whose schools can't offer advanced physics courses. To be a glass explorer means I get to tie together all the things that are most engaging about learning, you know, making every moment a teachable moment.
The first thing I'm planning to do with glass is take students with me on a virtual field trip as I go to CERN in Switzerland.
I'm excited to be here. All right, here we go.
Holy cow! Wow. Okay, I'm gonna try to get my brother's class in on this.
Okay, class. Hang out with Ryan's class.
Wow. Hello, everybody. Hi, Drew. Welcome to CERN. We made it. We're here. This is the CMS. That's incredible. This is one of the most complex machines ever made.
Wow. Very excited.
If we want to see back to the very beginning of the universe, the only way we can do that is with a beautiful machine like this. This tunnel's 27 kilometers long.
Fewer people have ridden a bike here than have climbed Mount Everest.
Crazy.
Does anybody have any questions?
John, how long does it take a proton to travel the whole loop?
How cold do the magnets have to be superconducting?
What is that?
If you added up all the protons in this entire tunnel, it would fit into the space of just one single grain of sand.
We can say goodbye to our trusty bike here.
Bye. Thank you, Steve and Freddie. See you. It's been a pleasure.
All right, I'll see you guys when I get back in Michigan. Even though I may never go to space, I still feel like I got a chance to be an explorer here at CERN. Unbelievable. And you know, while I wasn't wearing a spacesuit, at least I got to wear, like, you know, a hard hat and glass.
Woohoo! Dude, this is amazing.
Okay, so based on this video, we know that Andrew is using technology as instructional tools. May I get your opinion or your feeling regarding to this video? You can write it down on the chat area. I'm waiting for your opinion or your feeling based on this video. What do you think of Andrew teaching method? Yes, amazing effort. All right, it was in 2013. Okay, but today I reflect to myself, okay, I didn't use this kind of technology. Previously, I didn't use this kind of technology in my own class, even though I am in engineering lecturer. All right, so this relate me or reflect the way I teach my student, the way I deliver my content to the students. Yes, he make his students feel it and relate to the real world situation, right? So based on my reading, based on research in engineering education, it really reflect me and make me try to improve myself to deliver the content to my students. So I hope by having this kind of sharing session, I can share my experience and can give you thought example so that we can together improve ourselves. Okay, so that it can give a better impact to our students. Okay, so now we know Andrew is using technology as the instructional tools. However, these trends in education 4.0 should be related to engineering education as well. Okay, so here I listed 8 trends in education 4.0, and I can say that this can relate to the engineering education as well. For example, the first one is classroom free learning. It means that our student can have class at different places and at different time. For the flexibility, we give a flexible to our students to modify their learning process so that they can choose their own tool. Okay, they can choose their own tool that are suitable for them, maybe using different devices or different programs or different technique of learning. Okay, and the third one is personalized learning. Okay, this personalized learning means that students get their learning plans based on what they know and how they learn best. Okay, and mentoring, the trends in education 4.0, teachers, lecturer act as a mentor because students develop more and more independence in their learning processes. Okay, and practical application curricula, where in this trend, we give a room to our student, okay, to obtain real world skill. Okay, they can go for internship, they can have mentoring project with the industrial person, and what Andrew did in his class is considered as practical application curricula as well. Okay, project-based thinking, learning and working. As careers are adapting to the future freelance economy, students have to learn how to apply their organizational, collaborative, and time management skills in shorter terms to a variety of situations. Okay, and ownership. We give our students, okay, ownership where they can critique, they can give their opinion, and we take it as our input for our content or courses. Evaluation instead of examination. I can say that project can replace our current examination, okay, because we can have a performance-based assessment. All right, so that's one example of a future assessment. Okay, so based on these general trends in education 4.0, we can see that these trends cater few research areas that we discussed before, such as engineering learning mechanism, engineering learning system, and engineering assessment. If this general trend is expanded to a different diversity, then we can consider it as research in engineering diversity and inclusiveness. While if the content of the study involve social context, we can consider as research on engineering epistemology. This is how we can relate this trend, education 4.0, with the research in engineering education. Okay, so now we can see that we are using technology, and technology is another trend in education 4.0. However, how can we use technology in an efficient way? Here I share a framework that I refer to known as technological, pedagogical, content, knowledge, or TPAC. Okay, as you can see here, okay, there are three basic of knowledge. Okay, the first one is content knowledge. Okay, content knowledge discuss what are you teaching? What is your own knowledge related to that subject? So this is content knowledge. The pedagogical knowledge discuss how do your students learn best and what is the instructional strategies do you need to meet their needs and the requirements of your lesson plan. Okay, and the third one is technological knowledge or TK. This discuss on the digital tools that is available and you know about that technology. If you know that about that technology, then you can use in your teaching or in your classroom, right? So here, as you can see, there is an overlapping area. Okay, this overlapping area is the technological pedagogical knowledge or TPK. This overlapping area refer to the knowledge of how technology can be used or various technology can be used in teaching or various technology that can be used in delivering our content or our method of teaching. Okay, so next you can see that TCK, technological content knowledge, where this technological content knowledge refer to how technology can create new representation for our specific content. Only us in that area can understand this. For example, I am electrical engineering educators. I have my own subject to teach. So only me can understand how this technology can be used to create a new representation of that content to give a different experience or better experience to my students. All right. So this is TCK. Okay. The last one is this overlapping pedagogical content knowledge or PCK. Okay. This PCK refer to the content knowledge that deals with the teaching process. Okay, so you can see three basic knowledge here. When you combine the two, will give another level of delivering your content. But now when you combine all knowledge, it will give you another level where this is the main we can call it the main concept of TPAC, where TPAC is to understand how to use technology to teach concept in a way that enhances student learning experiences. Okay, for example, if you are using learning management system, okay, during this pandemic or before pandemic, you use the LMS. Yes, you use technology in your teaching method. However, if you just upload a PDF file in the learning management system or the LMS, it doesn't give a better experience to the students. So that does not reflect this TPAC. Okay, so you need to know how you can use that LMS to give a better experience or another way of teaching. For example, instead of giving the PDF file, you can share videos, all right? So that our students or your students can get a video, can get a better experience, right? And sometimes this video can give them a better imagination of the content. So this can be considered as another level of knowledge, where this considered TCK. You move from giving PDF to the video, then you are at this TCK level. Okay, when you combine it with the pedagogical knowledge, for example, relate to the assessment or grouping strategies, right? That use the technology, then we consider it as TPAC. So I use this framework to design my class using technology. So I hope by sharing this, you can get idea to improve the way you use technology to deliver content to your students. Okay. So next, okay, here I listed few technologies that can be integrated into our class. Okay, the first one, okay, technology related to the feedback and assessment. Okay, you can have prompt feedback, okay, as what I'm using in this presentation. I use Mentimeter, okay, and I use the chat area to get immediate feedback from you. Okay, I can use assessment. I can use Kahoot. I can use quizzes for the formative assessment. So this is how I can integrate technology in my class. Okay. So for researcher who are related to the technology, you can consider blockchain. Okay, for future research related to the feedback or related to the assessment, blockchain is a good research area that you can explore. Okay, so the second one is remote and virtual laboratories, where we can consider using virtual reality, augmented reality, or mixed reality. Okay, so this kind of technology can be integrated for remote and virtual laboratories. Cooperative learning. Okay, you can use learning management system. You can use Schoology. In my case, I'm transforming Gamers platform, Discord, okay, into my class. Okay, so I use Discord for this cooperative learning, as well as online social networking. Okay, the difference between this cooperative learning and online social networking is, for the cooperative learning is the activity that we have in our class. While for the online social networking, I'm considering students changing their knowledge, changing their material of study across university, across country, because of the presence of this internet. Okay, so that's why I consider this one as an online social networking. They can freely talk about the assessment that they have. They can know about the assessment that their friends from other country, then from this can give their input for them to take their ownership for that course. So this will be the future trend of technology and the future assessment in engineering education. And 3D printing. 3D printing, I can say it can be very useful for biomedical students. Okay, you can have that 3D printing to print the heart. Okay, so you can bring that into the class. Then the student can use to understand better, to visualize it better. All right. Hologram is another future technology that can be used in engineering, okay, to give a better experience to our students. For example, previously, when we bought a reference book, certain reference book come with slides, okay, with a lecture notes or lecture slides. I can say that maybe in the future we can create a education books, right? When an author sell the books, all right, it's come with the hologram. So lecturer or teacher, we didn't need to prepare the slide anymore. Our student can just watch that hologram, and they can get the information or knowledge directly from the author of the book. And us, teachers or educators, is to help them to get a better understanding during the class hour. So this will be a future technology. Biometrics. We can use eyes to understand or to get feedback from our students. Okay, maybe eyes can be used for emotion recognition during the class hours, or we can have artificial intelligence, okay, to help us understand our students better. For example, one technology used in China that used headband to analyze students' concentration during the class hour. Okay, and they use robot to monitor the students' health and engagement level in the class. So this is how AI can be used in engineering and can give a better experience, not for the students, but can give a better experience to us educators. Okay, so here I share this is how I make a transformation, what you call it, gamers platform, Discord, into my online learning management system. So this is something that we can look forward. So I think I have, okay, it's already 10:24. So this is my last slide, I think. Okay, since this is IEEE Society, so I want to share, okay, this publication for those who are not aware yet, where for IEEE, we have two publications related to the engineering education. The first one is IEEE Transaction on Education, where in this publication, you can publish a scholarly contribution to education in electrical and electronics engineering, computer engineering, computer science, and other fields that is under IEEE interest. Okay, the second one is IEEE Transactions on Learning Technologies. Anything related to the technologies that can be used to enhance your education, then you can send to this IEEE Transaction on Learning Technologies. Okay, so all right. So this is the reference that I use, and for me, pedagogy is the driver and technology is the accelerator. Okay. All right. So before I end the session, I want to get last feedback from all of you. Okay. So let me. Okay, again, go to www.menti.com and use the same code and write down your opinion or whatever you want to write, that what have you learned in my sharing session today. Okay, I'm waiting for you guys. Okay, to give feedback. Oh, okay. Wait, Okay, again, I share menti.com link and the code. Okay, I'm waiting for you to write down the point. What have you learned from this sharing session? Okay, now it's only 9 person who respond. I'm waiting for the rest. Oh, you are not able to fill in the form, so it is okay. I just Okay, thank you for the feedback. Okay, I hope my sharing session today give you a better insight and give you idea how, if you are beginners, how you can start research in engineering education. Okay, so I think I pass to you back, Mr. Varun.
Ma'am, before we close, can I have some questions? Hello, ma'am. Can you hear me?
Yes.
Yeah, this is Subish from IIT Madras. I'm doing research in engineering education here in IIT Madras. So
Hi, nice to meet you.
Nice to meet you. Very nice to meet you. So thank you for the wonderful presentation for the most significant topic, engineering education research. And You have been, as you rightly pointed out, this technology is the secondary part. The driving part is, of course, the pedagogy and the learning sciences, all those things. So you have been saying about integration of technology into learning and how we can integrate the learning sciences into learning, especially into engineering education. That is very important. I think we are still not addressing the elephant in the room. Just like there is no training for engineering educators, and the engineering education research is still taking baby steps. So how this can be improved from the global context, as well as from Malaysia, what are the things which we are doing, and even in India, you can see very few research is going into engineering education research, and there is no such subject related to the learning sciences in engineering curriculum. So how we can integrate those things? Unless otherwise we are integrating the basic pedagogical things, integrating technology is not going to work. That's my opinion. So I think we have to deal with the real problem and how it can be solved. Thank you, ma'am. Thank you for the wonderful presentation.
Okay, thank you, Mr. Subesh. Okay, I hope I pronounced your name correctly. Okay, I think we have the same experience, right? In Malaysia, I can say, even though we have engineering education society for a very long time, but moving to engineering education research is very difficult. Okay, and I can say that we are still in the early stage. But if I want to answer your question, how can we integrate the learning science, okay, with our research in engineering education? I can say that first is read. You must read. Okay, because that will give you this is based on my experience. Okay, if you I have a mentor in engineering education, Professor Khairia, founder of UTM CEE. Okay, what she asked me to do is to start reading. So I need to read. So from my reading, I start the learning sciences, right? When this learning sciences is actually talking about how people learn. Okay. When we know how people learn, then it will help us in our research. Okay. For example, there is a book of how people learn, and you can download that PDF actually. Okay. How people learn, one is people learn from prior knowledge. Okay. People learn from neighbor. We can say that in the class, from the peers, okay, and how assessment help people to learn. This assessment is, I can say, is the formative assessment when we get feedback probation in class. It will give us fast feedback to the students, and if you want to give feedback to the student, it must be within 2 weeks, because after 2 weeks the students will start forget about the activity or about the content. Okay, I can say based on the reading, based on the learning sciences, and under learning sciences, we can have that how people learn. It is actually indirectly contribute to our research in technology in engineering education. Because when we know that, okay, people learn from this and this, okay, now we will produce a technology that can help us to obtain this kind of things. All right, so it will happen indirectly. Okay, so you need to ask yourself, okay, how means that, for example, okay, the how people learn itself is one of the question that we can ask ourselves. How is actually we obtain the knowledge? How do we know the content? What is the best way of getting this kind of knowledge or this kind of skills? So by asking this kind of things, okay, it will help us drive us to the articles that can help us understanding the learning sciences or the connective studies that later will help us in our engineering research. I hope I answer you, Mr. Subesh.
Yes. Thank you, ma'am. Thank you so much. It's very clearly explained. Thank you. Thank you very much.
Thank you very much, ma'am. That was a very interesting discussion. Thank you very much for your time and your effort. We had a fantastic time with you. As a souvenir for this day,
I think Shruti is having some problem with the audio.
Yes, this is another challenge using technology, right?
Yeah. Definitely. And we have 2-3 questions in the chat box.
Let me read it.
One is from I will read it for you, madam.
Okay, thank
one
you.
is from Gregory and Gregory. Do you have any similar VR experiences in electrical engineering? I think
Okay,
in virtual reality.
I had tried metaverse, and it was in 2018 or 2019. I have tried metaverse. However, okay, I'm sharing my experience. At that moment, I didn't have a knowledge on the pedagogy. Okay, I didn't know about learning sciences at that moment. So when I implement that metaverse in my class, I have a problem. Okay, where I think that even though I'm using metaverse, I didn't see any changes in my students because my student is actually struggle using metaverse instead of struggle understanding the content. Okay, because of what? Because the lack of knowledge of the pedagogy. Okay, so we need to be very careful. Okay, when we want to use that kind of metaverse or VR, AR, MR, we need to really have a good plan. We need to really have the pedagogy knowledge so that it will help us to design our class plan. Okay, so we will give a better instruction to our students. We need to be focused on the content because we use technology to help our students to understand the content. So we don't want the students to struggle using metaverse. Okay, so that will not give achieve the objective of using technology. So I had used metaverse previously, but I can say that at that time I'm failed. Okay.
Okay, ma'am. Another question from Afandi Ahmed, UTHM. Any processing fees for these two publications in IEEE transaction?
Okay, it's sent to the other IEEE transaction. Okay, there is a fee. Okay, but I can't remember the amount. Okay, so there is a fee. I hope I answered.
Yes, ma'am. Yes, ma'am. That's all from the audience side. And also, I have a personal question to ask. What are the actually research areas in engineering education research in UTM?
Okay. In my case, I'm looking into the epistemology of engineering educators. So if we go to the 5 research area, it is related to the engineering learning system. Epistemology of engineering educators. Okay, that one is my research. Okay, and my other colleague, we do have research in assessment as well. So for the time being, I can say that we have these 2 of research area here.
Oh, okay, ma'am. And is UTM holding any current positions for PhD applications for international students?
Yes, PhD application. Yes, currently I have PhD students from Filipina. Okay, from Philippines. Okay, is doing about related to the curriculum. So you can go to our website. Then you can see what we call it, the procedure. Okay, to apply for PhD under CEE.
Oh, okay, ma'am. Okay, thank you so much, ma'am. Thank you
Okay,
so much
welcome.
for your time and effort. I would like to call Mr. Akash Vijay for delivering the vote of thanks.
Well, good evening all. I hope I'm audible. Okay, so well, let me take up this opportunity on behalf of the IEEE Education Society Kerala chapter to thank everyone for the part they have played in making this session possible. First of all, I would like to thank our respected facilitator for the day, Dr. Nurzal Effiyana Binti Ghazali, for this wonderful session. It was really a great experience and honor for all of us to be with her and listen to her fruitful ideas and perspectives. Thank you so much for that, ma'am. We had a great time with you. It was really indeed a great session for all of us, and you did a great part in solving our doubts too. And I hope that everyone had a great time with you all. And thank you very much for the time and effort that you have played in putting the session together. So, and as a souvenir of this great moment, we would like to have a virtual picture with you all. So for that, I request everyone to turn on their camera. So guys, please. Okay, I request everyone to turn on their camera.
The participants, please turn on the camera so that we can have a picture together.
Can you please take the virtual picture if everyone has turned on the camera?
Everyone, please turn on the camera so that we can have a picture together.
What's the
Is it done? Who is taking the photo?
Abhijit, Abhijit from It's of Kerala chapter, I think. Abhijit, hello.
looks like Abhijit is having some technical issues.
It's okay then.
Anyone from the student team can take it, please.
Yeah, sure. I'm taking just a minute. Yes, it's done. Thank you all.
Okay, thank you all. So, thank you, ma'am. Thank you for this wonderful session. Well, next, I would like to thank all the executive members of IEEE Education Society Kerala chapter as well as IEEE Education Society Hyderabad chapter for the support they have provided, and thanks a lot for that. Finally, I would like to thank all the participants who have been with us throughout this event, making it engaging and fruitful. Thank you all. Once again, thank you one and all on behalf of IEEE Education Society Kerala chapter. Thank you all and have a great evening. There's actually a slight technical issue with the feedback form. We'll be mailing the feedback form for the participants, so you can fill it out. You can check your mails and you can fill it out later. So thank you all and have a great evening.
Okay. Thank you everyone for the time.
Thank you so much, ma'am.
Thank you, ma'am. Thank you so much for accepting our invitation and attending this event. Thank you.
Yeah. Welcome.
Have a good day.
All right. Bye. Good
Bye.
evening, everyone. Bye.